Hello, sir. How are you? It has been a quite a few gap regarding the communication. At first, I want to say that I was in the Portugal and get back to Finland on the 23rd, and I started working from the 25th again. I got this mail from Clara on the July 2nd, and actually in Portugal I didn't actually manage enough time to take any preparation, so I started learning again from the 25th July. From this data, at first what I actually have done in within this like 7 or 8 within this like 6 or 7 days, this is the data. This is the data on the biocasu, and there is another data on the diesel casu, and I found another data which is actually a sample data, where there are this is mentioned the loading place, unloading place, fast loading place, and fast unloading places. So it's all about like maybe this is a sample data. I haven't I just watch this data, but did not focus too much because I need to learn something from you also about this data. But at first, I what I have done, I just upload this two file, basically this biocasu file and this diesel casu both file into the MySQL workbench. These are the file here. I uploaded three files, but I basically focus on this biocasu and diesel casu. This is the data which actually we have seen in the Excel file, which I just have uploaded here. So my point of view was that I was just doing some bit of search and research with some query, and I made some query like 5 or 6 query here to identify a different thing. Like at first I wanted to retrieve the kilometers and carbon dioxide emission for specific dates, like if I just run this code for the biocases, so what would actually come. At first I tried to find out the like date wise. It is actually a date wise retrieval of the data based on the kilometers and carbon dioxide emission for the biogas. And there are other also, like there are other like queries which is basically to identify the sum of the carbon dioxide gas emission for the biogases. So there are different queries. I was just searching and I was just doing on like to SQL query for monthly carbon dioxide emission comparison. So if I just run this code, what would actually happen? It actually express the data on that in which month for the biocasu, particularly which month the carbon dioxide emission was quite larger. So from this data I found like the the month of January actually had the big carbon dioxide emission summation based on this data. So there are several queries on if I just focus on like a query for monthly invoice bill and commission carbon dioxide emission comparison. If I just run this code, what would actually happen? It actually express like the total monthly I have found like in the biocasu query for the January, this the invoice amount was quite big, and the carbon dioxide emission was quite big, whereas also found that this month maybe the actually the vehicle had moved a much more kilometers than the other month. Here I found that in the February maybe they have a less movement, so the kilometer is very less than the other 2 months. So these were some query I was actually working on. So basically here I have done a special query, just want to mention in the final. So like the same thing actually I have done in the diesel case also, where I found like the SQL query for monthly invoice bill and carbon dioxide comparison. So if I just run this query here, so what would actually happen? It would happen in the same way that in the diesel, where what we have found that the carbon dioxide emission in the biocasu is very less than the diesel casu. Okay, so like in comparison, like in the January, I have found like uh, okay, the vehicle actually moved 97,346 kilometer. It's a total kilometer movement in the March, where the carbon dioxide emission was just 383.37 kg, whereas in the diesel case the carbon dioxide emission was quite big, where the kilometers were very less. Okay, so these are the thing, and after just doing this kind of querying on this file, I finally try to compare this both query to identify and basically focus on particular three queries, where to identify what is the total number of trips, total kilometers travel, and total carbon dioxide emission for both diesel gas and biogas, broken down by source. So here I want to show something. If I just run this code, what would actually happen here? uh, if I run this code here, so like it will depict the trip count. Trip count means the number of movement from one place to another. Okay, so here it is mentioned in this file that how long they have this trip based on this load, based on this load. This is actually the ID and the load. This is the counting. That is the result of this trip count. Okay, so I just sum of the kilometers here for the diesel casu, and sum of the carbon dioxide emission, where it is find like for the diesel casu the summation of carbon dioxide emission was quite big than the biogas. So I wanted to express this thing into the Python by just connecting my MySQL database. So I did the MySQL database connectivity here, where my user ID, password, and host is mentioned here. My database here. So if I just run this code, what would actually happen? I would want to show this. Yes, this is the graph where I found, if I just get here, I minimize this thing. So what would actually happen? Here the amount is actually showing in the diesel casu 18,039. So this is the carbon dioxide emission which is depicted here, and where we found, we observed that in the biogas it's only 1093.27 kg. So based on the my focus point was also not only the carbon dioxide emission as well as the total kilometers, where it is very significantly shown here that the kilometer where that the portion of the biogasu kilometer that is very higher. Okay, so like the 2,70,516 kilometers actually travel, so the value is quite longer than the diesel gasu, so it actually represent here in this graph. Okay, so then I try to focus on a special thing, that is that there is another query before going to this final one. I just want to show that what is the total invoiced amount of carbon dioxide. So I want to just show the not only the emission, carbon dioxide emission based on the trip count and the kilometer. I also do this thing based on the invoiced amount. So if I just compare these two query here, so I want to show that what is the result. Like if I just run this query now, so what would actually happen? uh, Sorry, sorry, sorry for it. So if I run this query, what would actually happen here? uh, Yes, this thing actually showing us the every month what is the situation, what is the condition situation of the data based on data of emission of the carbon dioxide based on the invoice amount for in each month. So like if we, here we can see that in the for the diesel casu data, the March data is showing that the invoice amount was 67,638. maybe it's euro or something, and the carbon dioxide emission was quite big than the like the biocasu, where invoice amount in biocasu was quite big. It's it's an observation for me also, like why this thing is actually reversing for the biocasu issue, why the invoice amount for biocasu is much more larger than the diesel. So it is also in my my question and my query also, and I have some confusion also. Maybe there is some relation with the carbon dioxide emission. It requires, I don't know what is the reason behind this, that why the invoice amount is quite big, whereas the carbon dioxide emission is quite lower than the diesel casu. Whereas in the comparison, when I compare with the data of the diesel casu and biocasu, where invoice amount is quite lower of diesel casu than the biocasu. In every cases, I found that the invoice amount for biocasu is quite bigger than the diesel casu. So it's an observation also, or like maybe there is something what maybe I couldn't understand. I need to clarify. So at final, I want to I also have acknowledged this thing. I what I have done to identify the calculate the carbon dioxide emission per kilometer. Okay, so I just did this thing only for the diesel casu, and I have the same thing. This is the same thing. I just put it here. So I have done this thing only for the diesel casu now, but I haven't tested it for the biocasu. I will show it in the future. So here what I have done in this file, my understanding from the data, which was like I have just make a summary. Now I want to show the summary here. The for the biocasu, what is the how the calculation of LVP actually done here? LVP actually is the multiplication of the invoiced amount and the multiplier. So here we have found that I have just noted down here that what is how the LVP is actually calculated. It is actually calculated between the multiplication of invoice amount the multiplier, which I have mentioned. So the next question was like the consumption per vehicle x kilometer. So here is the maybe the question consumption per vehicle x kilometer, which is which is also I have just find out here. This is the multiplication of kilometer and consumption divided by 100, so the value will be here. So share of capacity is another file, another column here, share of capacity. So how to identify the share of capacity? So share of capacity is like the to divide the LVP by vehicle capacity. Okay, so vehicle capacity, um and this is the vehicle capacity. So if I just move this, so this is the vehicle capacity. The share of capacity is just identified by dividing uh, dividing LVP by vehicle capacity into 100. So the share of capacity would be just enumerated here, and share of consumption, how it is determined, the next column, which is the share of consumption. This thing is actually determined here like the consumption per vehicle per x kilometer into share of capacity. This like this column q and this share of capacity, if we do this thing, we found that the share of consumption is written is just determined. So carbon dioxide emission, finding out regarding about the GLEC structure, we know that the portion is 2.65. So if we just multiply the 2.65 with the share of consumption, which we have just determined here, so the carbon dioxide emission is actually finally come to the come to the carbon dioxide emission is just it is just determined by the multiplication of share of consumption with the GLEC ISO 14083, the format where the GLEC value is 2.65, which has to multiply with the share of consumption, and then the carbon dioxide emission is actually determined. And the same thing is actually for the diesel. I have also done this same thing here. This is same, but I have some confusion about this thing, like the portion of capacity used, the portion of consumption used. So this and the coefficient. So the thing is quite same as the for the biogas issue, but like I have some confusion with this, like the heading, the coefficient, where it was mentioned in the diesel biogas as a multiplier. So I have some confusion, but that's the thing is quite same, like the share of capacity which is mentioned as a portion of capacity used, and share of consumption is like the same thing is portion of consumption used. So I just calculated this all the table and found the amount is actually properly matched based on this theory. So here last 7 or 8 days what I actually have done, that is to identify uh, this like 2 or 3 queries, and I have almost done other queries also here, but I focused on this I not only focused on these all queries. I have to find out this special these 3 query to identify something. So now what I have just tried to do, that is to identify the emission intensity. The emission intensity means in the in per kilometer what is the amount of carbon dioxide emitted. So this is the formula what I have just here depicted. Divided the uh, carbon dioxide gas by kilometer. So it's actually find out in per kilometer what is the portion of the carbon dioxide gas is actually emitted. So I just define this emission intensity from here based on the data and the load ID. So my point of view was like to do some machine learning thing uh, for the analysis. So especially what I have done, I took some help of some YouTube channel to identify how to actually do something with the machine learning. So here to identify the uh, the accuracy of this data. So I was just searching in the internet that which machine learning could be helpful to identify some good portion of that how this actually file is quite compatible based on which clustering method or which machine learning is much more compatible with this. So based on my some kind of search and research, I found the k-means clustering is uh, much more compatible. So I found the similarity score analysis, which is far more best to find the emission intensity, where it not only actually giving us any random analysis, rather it is much more precise to identify any value by the technically, and the decision with based on the decision making. So this analysis actually what is actually important for this analysis, that how important is this analysis for identify that the value does it deliver for this emission intensity digital category is quite accurate. So here I want to show that this emission intensity contains actually two type of thing, that is like a vehicle or load data level, and where including kilometer, carbon dioxide, and emission intensity. What I am just showing here, that we consider the load ID based on the kilometer. We consider load ID, and we want to analyze this k means, the silhouette analysis. So based on this kilometers, carbon dioxide gas, and emission intensity. So for this k means analysis, there requires a clustering thing. So the data which the query which have been depicted here it is actually a query for like the data here we have for the diesel case was like more than 1100 and 1168 row is here. So the data is actually the data for the 1168. So I just what I have done, I just extract this query, and this is the result of this query, the same data. So first of all, the k-means actually works very intensively, and this algorithm is actually when the file is actually uploaded in to pursue for this algorithm, it automatically actually depicted it automatically separated the cluster method, like two or three clustering process they actually this algorithm actually works. So when I just upload this file, it automatically upload this file and mention the cluster I need just analysis for three clusters. So when I mention this three cluster equal 3, so automatically it analyze the data, and it find out that the lower portion of data will be just driven into the cluster 0, and similarly the upper portion of the carbon dioxide emission, the amount which will be just distinguished in different cluster. So here the lower portion is actually the cluster 0, the just slight bit of upper portion of the data which is the cluster 1, and another portion is the cluster 2. So here cluster 0 is has been started from the minus value to like up to like this. If I just go very lower here, so like yes, uh, it actually take the cluster up to 0.21847. Up to this portion it actually take the cluster 0, and after that it started from the cluster takes the data and analysis it automatically into its cluster. Okay, so it drops the other data into the cluster 1, and finally the bigger emission which is actually the it automatically put the data in the cluster 2. So my analysis was to find out how accurate this data is. So this k-means have some the score thing, the silhouette score. So silhouette score actually define that the if the score is higher than 0.05, so it means the vehicles are well grouped. Okay, so I just focus this data based on this load, because the vehicle is just one vehicle here. The vehicle id is just one id, that is xpt102. So the vehicle id in every row is same, but the load number is different. Okay, so I just determine that I have to do something with this load number. So how the silhouette code is working, it works based on this load data, which has that clear relation with every other, like the kilometers, the vehicle, everything, like each and every load data has separate value on the kilometers, and on every row, like this thing, the consumption per kilometer, every value is different. The consumption vehicle, every value is different here. The load data is different, and their value is different. Okay, so here the thing is, need to identify by this machine learning that how this data is uh, quite good. To identify the structure of this data is quite good. So the silhouette score is actually working to identify if the silhouette score uh, actually determined which is greater than zero point 0.5. It means that the data of the vehicles are quite well grouped, and the emission category are quite distinct from the other clusters. Okay, but if the data with the silhouette score is low and negative, so it means the some vehicles might be misclassified. Okay, so now we need to just think, we just need to see that what would actually happen by doing this thing. So I just upload this data. I got some view from a YouTube channel where I got how they are actually calculating this thing. So I take their help, and I personally talk with this person in in the WhatsApp and in the like YouTube, and he just gave me some good views personally. In the personally talking, I have some confusion still, but I'm trying to understand this, so how it actually works. So at first, I just declare a variable where I just put this the cluster into three, because the cluster, the how the amount of cluster is lower will represent a very good data, the data amount. If we make much more big clusters, so there is a possibility that the amount the result wouldn't be quite acceptable. So I just got this information from that guy, that you just have to take the cluster very lower to get some good data. So at first I took the data for I determined the data for cluster 3. So then I found that the k-means inertia, this what actually means. The inertia thing actually is the like it's actually metric. The k-means which actually works to determine the clustering that represent the sum of like square distance. Okay, so distance, how the distance is actually worked. If I this I know maybe sir, you have a very good you know about this k-means thing. So if we identify like just three sets here, if we identify three sets like that, there are another two sets like here, this is a cluster 1, this is a cluster 2, and this is a cluster 3. If the data is actually here, the lower data is here, the middle bigger data is here, and the big data is here. So we need to find out the distance, the data which is actually inside the cluster A, which requires a specific thing to identify the distance between the data. So a special uh, equation is required to identify the distance which is inside the cluster, same cluster, and the data which is actually in the other cluster, it requires to identify the distance from one cluster to another cluster. So it is important here. So after just doing this doing the analysis with the cluster 3, this inertia thing actually depicting the more speed out the data, which is the higher in the inertial value. So it means like the closer the data points are to the cluster center, the lower the inertia value. So after doing this thing, the finding out the inertia, we found the for the cluster 3 the amount is like the 599,000 59900 and 080. See, this is the inertia. But if we do if we just increase the cluster here, I also do this thing in the letter, that to increase the cluster uh, in 4, if I do this thing here also in 4, if I run this code, it would actually give the much lower data. So it's like 399,860. So when I just increase the cluster from 3 to 4, the inertia value of this k means actually getting lower. So which has a very big chance that the data can be manipulated, or data cannot be quite accurate. So then I identify the cluster center. The cluster center data is actually the very crucial point to this data are the center data. Okay, the center data which is very close to the k-means. So then I run this code for to identify and show what is the data here, what is the shape of the data. So this actually here I have taken this two because I just want to remove the first two column and I have to focus on this two three column, that is called this two. So I found this data shape here, and then I take the like the lesson from that guy to identify the range, what is the amount of this cluster. um, so these are the data. Actually just put I got this, what is actually identified by the range of a for loop from 1 to 20. So this range is very low. If we just analyze the range much bigger, maybe that there will be some misconception with the data structure. It wouldn't give me it wouldn't maybe give us a proper result. So I just analyze for a 21 to 19. 19 loop has been just here just move, and the analysis of the data is this is like the 2020 data is here from 0 index to 19 index, and the data is actually just stored in the A. So and then I try to plot this thing. Okay, so we know in the K means there is a like this is the actual the formula, the similarity formula, where is bi minus ai, and it has to be divided by the maximum ai and bi. So here we have found everything, and finally we found that this is the the array which have been actually depicted uh, for the value 3, and we have the length for like 1168. So we already have this the inertia value. Now we need to calculate using the formula, and we just take some array from here, and now we finally go to this um, machine learning coding here, I have taken some advice from that guy from YouTube, who actually helped me a lot. I will describe this when I have a face-to-face meeting with you. Then this code actually returns the value, that is the score is 0.73, the manual silhouette score, which is 73. It actually works on the cluster thing. Basically, the at first we put the data into the d variable, and then we call the silhouette val, where we have to put this is the data. This is the data which is actually stored in this, which we are just printing here, just calling this there is this function. So what I have done, we just did a just a loop which actually working with this length data, because we have 1168 1168 data here. So we put the data into the current cluster. So and then we analyzes this cluster and compare this cluster uh, from current cluster. So we did this thing, and then we try to find out that what is the distance. So here is the distance thing actually working. We analysis with the if else method, that how the distance is working here inside a single loop. This is actually the distance calculation of one cluster. That means like this one, a single cluster within the a this distance is just working here. And after that we analyze the second analysis on this if else, and here is the for loop is working for to analyze the data, the distance from one cluster to another cluster. This code is working for this thing. And then we after just depicting these two things, we are just putting this into the like the formula what we have seen here. This is the formula. This formula is now here we have mentioned here in this. So this is the formula. This is the formula, and then we just appending this data into the silhouette val. So after appending this thing, we found that the silhouette score is 0.73. It means that this data is quite a good, have a good quality. And at the first we have just found out here that we come to know that if the silhouette score is greater than zero point 0.5. So we found that our score is here, which is 0.73. It depicts the 0.73. The manual silhouette score is 0.73, which is completely bigger than zero point 0.5. So it defines that the data is well grouped, and the emission category and distinct in each other to other cluster is well identified. So this is something what I actually try to learn in many ways. But last couple of days, now I want to show one thing, that my interest point was to do something with the Google Map and some other thing, where my interest is I want to show something that what I was trying to learn. This sample data is actually depicting us the loading place, unloading place, and the fast loading place. So my intention was, if there is something is mentioned here, the kilometers. Maybe this data is a very good data, and this is a sample data, and it has been defined by some like some like OBD2 thing. Maybe this device is actually available in every car, in every vehicle, which actually has the storing capacity of data of every movement of the vehicle. So maybe this data is coming from there, but my point of view was to identify that the where where the vehicles are actually moving, and how could we find the distance using the Google Map. Okay, so then I was doing some coding based on this analysis, where I found, like if I just go to this point, and if I want to show that this coding is actually giving us some data on, we wanted to at first focus on this Yamsan Elonen Oi. So I found this address. It is the Pataladenkatu 142100 Yamsa, Finland. It is actually, I have found this address in the Google, and the Nurmo Logistica Keskus Oi. It's actually situated in the Vasanti 160100 Seneoki, and the last one is Venia Little Yakelu Keskus, which is actually situated in the Lento Mananti, is 4180 Venia, Finland. So what my intention was, I can now identify the longitude and the latitude of this location by this Python code. So if I run this code, what would actually happen? If I want to show something, that if I run this code, the Python is actually identify the latitude of this position, that Yamsan Ilonen Oi address. This is the latitude is 61.84, and the longitude is 25.22, and the distance sorry, the longitude and latitude is very identically actually identified by this code. So my next point was to, how could I actually clarify the distance and the kilometer, which is actually, if someone actually give me the result in Excel file, if I want to clarify that Excel file data is quite okay or not, so how could we do this thing? So I was just trying to learn some thing from internet for a couple of days, and if I want to put this thing, the data is here, the Yamsa Ilonen, the latitude of this was like the 61.84. This is the data, and the longitude is 25.2247089, and destination is 62 point destination was the Nurmo Logistica Kesku. So I was trying to identify the distance between the source, that is Yamsan Elonen, to Nurmo Logistica Keskus. So this is the distance, the source longitude and latitude, and the destination longitude and latitude. And if I just run this code here is the code. If I run this code, it actually detects us the distance between these 2 points is 87.9 kilometer, and it requires like 16 hours and 0 minutes. Okay, so if after that, what my target was to to do something to show the path into the Google Maps. So I take some lesson from some guys in the YouTube, and I got some good view from their data, and I take some code from them, and want to learn how this actually work. I will show. I will definitely try to describe this in the future, but now if I just run this code, what would actually happen? This is the thing actually showing here. It actually take the data from the Google Map. Okay, so this is the data. If I just now zoom out it, so this is the distance. Okay, so this is the source origin, which is Yamsa, and that is the destination. So if you just uh, zoom in the place, so what would actually happen? It would actually take us to very close to this location. Okay, uh, this is the location from where maybe the track has been I can we can show maybe there are some vehicles are over there. So there are some trucks are over there. Maybe this is the Google data, but using in this is the OpenStreet data, but in backend it's the Google data is working behind this. So if we just show this, there are some like cloud and everything is showing here maybe, and this is the path which the vehicle actually has to follow, and maybe this is the path actually going very straight to its destination, and the distance actually calculated here, and it has some point where it takes to uh, location, where if we just target into this, this is the place. Maybe this is the place of Nurmo Logistica. Okay, so this was actually I was trying to do something with this thing, but there is a good thing uh, another from another guy in the YouTube. I had a good discussion with him. He actually did some work with the OBD2 data, OBD2 device. It's a app where he actually has this thing which he actually note out, and it this data is very accurate. Is very accurate, this data, because this data is actually he has taken from that OB2 device, which is actually has a good setup in his vehicle, which works very clearly, and every corner, every position of the road is very accurately actually it depicts there, and the longitudinal latitude, everything is working very so fine. And this the coding thing is very difficult, and difficult for me. It has actually working on the very precisely on the longitude and the latitude with the division of 360 degree and other degree in different position. I had a personal talking with him, and he showed me he shared this like this small this that URL. It is actually in his server. I got some access by personal communication with him. So I got this structure of the programming from him to know about this thing. At first it was blocked, but he gave me some access to identify, because I show him some interest about this thing. So maybe it works, but maybe it would be tough to incorporate into my project, but maybe there is a scope to incorporate the previous thing what I have shown here. This one is using the Google Map, maybe quite okay. This is the thing. After for last couple of days, I was trying to learn, and eagerly waiting for your kind advice. Maybe the video gets actually very longer than the usual one, uh, but I'm still trying to learn something new thing. I am using the Jupyter as well as the Python in different platform, using the PyCharm and using the VS Code to identify this thing. Maybe in the future I have to just do this thing in the common platform. Maybe it is possible, so I have to learn something new. So that's up to the mark. Maybe it gets quite bigger, but it takes too much time to express my feelings. So I would be so hopeful that I would get some valuable advice from you very near. And if you just give me permit me, I'm available to meet you at your convenient time. Thank you very much, sir.